Okay, let's do a quick review of the lesson of the day. We started up with the warm-up problem, and what we were asking here is to find the three forms of the equations of a parabola given a graph. So we are looking for the vertex, intercept, and standard form of the parabola. Let's first of all write the generic equation for those forms, and we know that the vertex form is y equals a, then multiplies x minus h squared plus k, where h and k are the coordinates of the vertex and a is the scale of the parabola. The intercept form is written as y equals a, then multiply x minus p and multiplies x minus q, where we call p and q the solutions of the x-intercepts of the parabola. Standard form is y equals 2x squared plus, standard form it's y equals ax squared plus bx plus c. And again, this is a. The only thing that we know about standard form, the only real term that can be read directly by the graph is c, and c we know it's the y-intercept. So in this case, c will be 4. So let's start with the vertex form. As we said, h and k are the coordinates of the vertex of the parabola, the x and the y. In this case, the x is minus 2 and the y is 0. That's where the vertex is located. This is our vertex right here, and the coordinates of the vertex minus 2, 0. So we can rewrite this vertex form as y equals a x plus 2. Again, we had a minus 2 with the minus here. We have a plus 2. This is squared plus 0, because our y coordinate is 0. The only thing that we are missing to complete this exercise is a, is this value, the scale of the parabola. And we can find a fairly quickly by plugging in, just looking at the graph and plugging in a number of values of y and x that satisfy the parabola. So we can pick a point on our parabola and substitute the value of y and x on this equation. So let's say I pick the y-intercept, my 4. In this case, my coordinates, the coordinates of that point are 0, 4. If I plug those two numbers in, I have 4 equal a x 0 plus 2 square plus 0. And again, I'm going to drop the 0 now, as we know that was representing the vertex, the y coordinate of the vertex. So a can be found as 4 equals a 2 square or a 4. If I divide both terms by 4, I can find that a is equal to 1. So we can write our vertex form of the parabola here, and that would be y equals 1, or we can leave it blank, x plus 2 square. Now, what about the intercept? Well, first of all, we know that a is 1, so we don't need to calculate it again. The only thing that we're missing are p and q, but we know that p and q are the x-intercept. Now, this parabola is a little bit tricky because it's touching the x-axis only once, or at least that's what we think we see from the graph. But in reality, as you know, this is a quadratic and we always have two solutions. This is, you can imagine that this is touching this point twice. So the solution for this parabola are actually -2 twice. So P and Q are -2. And this formula will be y equals x plus 2 that multiplies x plus 2. And again, as you can see, this becomes very easily as the same as the vertex form. Now, let's look at the standard form of the parabola. Now that we have the intercept, we could easily find the standard form by foiling this equation here. But we already know that a is equal 1, so we can write that y is equal x squared plus bx plus, and we know that c is our y-intercept, and in this case is 4, so we can write 4. The only term that we are really missing is our b, and we could find b simply by picking picking one point that is on the parabola and substituting the value of x and y on this equation. Or again, we can FOIL and find our standard form. So hopefully this is enough to refresh your memory on how to find the three forms, the three equations given of a parabola given a graph. Let's now move to our solving by factoring. You remember that our objective to solve a function, a quadratic function, is to find the solutions of it. And unfortunately, in many cases, when we have an equation like we have, for example, here, this equation that we have here, it's not very easy to find the value of x where our quadratic equations find the solutions of x where the quadratic equation is actually crossing the x-axis. So we have to find a number of techniques to simplify this expression to a point where we can easily isolate our x. We've done already completing the square. Solving by factoring is another method. So first of all, let's talk about what are the solutions to a quadratic function. We discussed it already at length. Solutions of a quadratic function are the value of the x when y is equal to 0. So it's where our parabola crosses the x. What are the names for the solutions? The other names are zeros, roots, intercepts, and so on. So, what is solving by factoring? Well, first of all, factoring takes advantage of a very simple mathematical fact. If I have two factors, two terms, a and b, and I multiply a and b, and I know that the product of these two factors is 0, it can mean three things, okay? Either a or b is 0, or both a and b are 0. So that this is the only case when a times b can be equal 0, only when a or b are 0 or both of them are 0 at the same time. So if look at this quadratic here that has been factored already, you can say that the only time when these two this equation can be 0 is when either of this factor is 0, or when both these two binomials, in this case our factors are binomials, when either of these two binomials is 0, or when both of them are 0 at the same time. So if I want to find the solution of this particular quadratic equation, I can just set 3x minus 2 equals 0 and x plus 4 equals 0. So my solutions are going to be x equals 2/3 or x equals minus 4. Okay? So we could find the standard form of the quadratic equation above by FOILing, and if we FOIL this equation, we have 3x squared plus 12x, then we multiply minus 2 times x, so minus 2x, and then we multiply these two terms, minus 8. So the final form would be 3x squared plus 10x minus 8 equals 0. Okay? Okay, what are the solutions for the following quadratic equation? We've seen this morning that to find the solutions we can factor this trinomial so that we can go back to a form that's similar to this one. So let me connect it. We are trying to go from here to this form to a form that's similar to that, okay? And I don't want to confuse you too much, so I'm going to take this away. So how do we do that? First of all, to factor, we need to, as you can see in the steps here, to find the factors, we need to factor this trinomial, we need to find the factor of c that add up to b. Okay, so we need to find the factor of c, in this case is 18, this is our c, that add up to b, and that's minus 11. Okay, what are the factor of b, of c of 18 that can add up to 11? If I have, to minus 11. So if I know that 9 and 2 are two factors of 18. So if I multiply 9 times 2, I can get 18. However, when I sum these two numbers up, I'm getting a positive 11. But if I change both signs to minus 9 and minus 2, again, when I multiply them, I still get 18, but when I sum them up, their sum is minus 11. So once I have these two factors, I found those two factors, I can rewrite my equation as x squared minus 9x minus 2x plus 18 plus 18 equal 0. As you can see, I didn't change anything, because the only thing I did is split the 11 as the sum of the two factors. Okay, so this remains the same. But what allows me to do is, if I can split this equation in two. Okay, and so let me write it down more correctly here. Minus 2x. If I can split now my trinomial into different parts, and I can simplify this by writing the first part as x, that multiplies x minus 9, and the second part is I can see that I have a 2 in common here. Okay, so I could write minus 2 that multiplies x minus 9. Okay, and again this is equal to 0. But these two terms are the same, so I can rewrite this once again, x minus 2 then multiplies x minus 9 equals 0. So as you see, I have come up to a form, and I can rewrite it right here if I want to, that allows me to now simply find the solutions to this equation. The solutions are going to be x minus 2 equals 0 and x minus 9 equals 0, so x equals 2 or x equals 9. For these two values, this trinomial is equal to 0. So I have found what I was looking for. I found the roots or the intercepts of my quadratic. One thing that I did not stress is that the reason why this thing works so well is because our a is equal 1. If a is not equal 1, the thing gets a little bit more complicated. So for now, let's just make sure that a is equal 1, and when we move forward we can see what we can do when a is not equal to 1. But anyway, you can do the next one on your own, and I think we can conclude this simple lesson.